Hi and welcome. I'm trying to learn electricity, today power stations, and in the second half of the video after it we're going to do wrist training. And if you participate in wrist training, that is at your own risk. Now it is the second part where we're doing power stations, and we want to make now a little presentation and saying a little very broad overview about how power station is structured. But first, let's read with one sentence here in the explanation at the beginning. In a modern gas-fired power station, the hot exhaust gases from the burners are used to turn the turbines and then to heat water to steam, which turns the turbines. Okay. The gas is burned. And this gas is burned in the burners, and out of them. And these gases coming out of the burners are turning the turbines. And after they have turned the turbines, this gas is used to heat the water to steam. And that water then turns the turbines. Do we mean that that the gas is used twice? But it can be used, the exhaust gases of firing of a gas and the thing which had been heated with the firing of a gas, the water. I understand it now that way, that both can be used. The exhaust gases of the burning of a gas itself can be used to turn a turbine, and the water heated through burning of a gas, the water which is turned to steam to turn the turbine. So it can be used double. I don't really understand it, and as I said, that sentence just adds 5 times complexity. We're gonna stay by our coal-fired power station. Okay, the video which we're gonna do is our presentation should have the name broad overview of a structure, or the structure of a coal-fired power station. We're having the big in the furnace. In the furnace is the Burnsby oven. I don't know what a furnace is. I'm gonna call it oven. In the big oven, there is coal burning. But coal is brought by trucks and trains. And in the middle of that burner, that oven where it is so hot, there are pipes with water. And now the water inside of these pipes heats up and becomes then steam. That steam then is expanding and is pushing through to turbines. And now that hot steam pushes against the turbines, and that pushes them to one side, and then it pushes again onto the next part of the turbine, of the next branch of the turbine. I call it the branch of the turbine. And now the turbine turns, and the turbine turn then is connected to a generator, and there the turning turbine makes also the generator turning, and that then inside the generator generates electricity. The rest of after the water is cooling then while making the turbine. Why is it brought into cooling towers to cool it down? But this is more than just catching the water. So it can be heated again. What is the advantage of heating steam again? It pushes against through it. If it would be just hot, it wouldn't. No, we're talking about electricity here, not about thermodynamics. Why is it then brought back and cooled? My first guess is now, if it would be just hot, it would be just standing. Just because it was cold and smaller, and now heated and it expands, it pushes into the pipe and pushes against the turbine. Otherwise it would just stand in the pipe. Only for bringing it into the cooling tower, where it gets cold again, and we're having cold water again, we can heat it again, and it can expand again. That is the way I understand it. But actually, if it is not explained yet, that is in a way a central part of the diagram, and I'm a bit wondering. If a question does not logically come up, now, are we able to save it? With graph, yes, and we're going to use the graph. Problem is I'm standing too far away from the camera. Now I can see the graphic, or the diagram. It isn't even written here what it is. I'm going to call it graph or diagram. I have a second camera I'm going to start with now. And now we're trying to do our little short video, which has been the title of Structure of a Coal-Fired Power Station. The basic structure of a coal-fired power station. So there is a big oven, and in that there's coal burning. The coal is brought by trucks and trains. And in that oven there's the coal burning, and wherever it's so hot in the oven, there are pipes coming with cold water, and that cold water then heats up and becomes hot water and then steam. And that steam pushes then onwards out of it to a turbine. And it pushes against the turbine, and then one of the branches of the turbine is pushed, and the next one, and all is pushing against it, and now the turbine is turning. Because now the turbine is turning, we can use the energy by a connection to a generator, and the generator is also turning. So we're making the turbine turning, and then we're making, with the help of the turning turbine, the generator turning. And if a generator of electricity is turning, we can create their electricity. That electricity is then brought to a transformator and changed in voltage, and then brought to all the homes and houses. The water which has been in the turbine is brought then into the cooling towers, that cools down, and when used again, brought into the oven, heated with the new coming coal, and when it goes back, heated as steam, turns the turbine, and so it goes on. That was a broad overview of the structure of a coal-fired power station. I'm going to stop for a second camera. And that was that chapter about the power stations. Now, if you're here for more about electricity, then you can go directly to the next video. Maybe the power station, the next one. But if not, I thank you very much, and until the next time. And we will do now the Wristtraining. If you participate in the Wristtraining, it is your own risk. We are starting with the 4 days new Symphony as director. The fists next in front of us, and we're opening them, and we're closing them. We open again, and we close them. And the next exercise, the T-Rex in the morning. Flat hands out, and we bring them down, and up. Again down, and up. And the last time down, and up. And now with T-Rex in the gym. If you don't want to use or can use a tennis ball, then you just make a strong fist. And we are pressing on the tennis ball. And release again, and press again. And release, and press again. And on the other side, we are pressing on the tennis ball, releasing, and we are pressing again, and releasing, and the last time we're pressing, and releasing. Next exercise is the cautious big bang. Place the fingertips of one hand on top of the fingernails of the other hand, and open slowly, pressing a bit against it, close again, and open slowly. Now we're changing, the other hand on top, open slowly, close again. And for last time open. And close. Next exercise is the bicycle bridge. Flat hands, and we're bending them into knuckles. Hold it for 1-2 seconds. Open again. And again the bicycle bridge. Hold it. And open. And again. Next exercise is the ice axe. Flat hand. Bend the knuckles and press on all 4. And open it. And the other hand, bend the knuckles and press on top all 4. And open again. And I think our last exercise, we are making the claw. So just make close, hold it for 1 to 2 seconds, and open again. And close, holding, and open. And the last time, close, holding, and open. And that was the restraint. We don't need to. I thank you very much, and until next time.